Hello everyone, class 12th. Topic is reduction of ester to prepare alcohol. In previous videos, we have understood how we can prepare alcohol from aldehyde and carboxylic acids. Here we have another organic compound which can prepare alcohol, that is ester. The general formula of ester is RCOR, this one. Both oxygens are carrying two lone pairs. Now ester is made up of two parts. This part, which is known as acyl part, and this part, which is known as alkoxy part. Now when we will reduce ester, we can get alcohol. Now first, let me tell you the trick how we can directly reduce it and which reducing agents we can use to reduce up to it alcoholic stage. This is ester. For its reduction, you can use these reducing agents. Number one, direct hydrogen gas in the presence of catalyst. Second, sodium in the presence of ethanol, C2H5OH. And third is lithium aluminium hydride. These reducing agents you can use. Now how to reduce it? Watch. As I already told you, reduction means loss of oxygen. So first you need to reduce the bonding with oxygen. This carbon have 3 bonds with oxygen. Now when it will get reduction, out of 3, 2 bonds will left with carbon, means out of these 3, 1 bond will break. Which bond will break? Obviously pi bond, which is a weaker bond. So when you will break it, this you will get. And obviously valencies are not satisfied, both of oxygen as well as carbon. So their valencies you will satisfy by hydrogen. Now watch carefully. I already told you about this condition. Carbon with 2 oxygens like this. Unstable condition because 2 oxygens are feeling crowding or steric hindrance. In such condition, 1 oxygen will break bond from carbon. This oxygen is breaking. And both electrons will go with with oxygen, because oxygen is more electronegative. So vacant orbital will generate here. That vacant orbital will be satisfied by this oxygen by bringing these 2 electrons here. So between this oxygen and this carbon, double bond will generate. Hydrogen as it is. Now this hydrogen will release out as H positive because it is losing its electron. So H positive, and from here alkoxy part will generate out, and oxygen will carry 3 lone pairs with a negative charge because this oxygen got 1 extra electron of carbon. Now this H positive, this negative will combine to produce ROH. Means alkoxy part will create separate alcohol. This one. Wait. Reaction is not ended yet. What we got? This acyl part turns to aldehyde now. Can we reduce further aldehyde? Yes. Aldehyde will get further reduction, and again, what is the technique? Now we have 2 bonds with oxygen. Next reduction will break this second bond. H is there. Now satisfy the valencies with hydrogen like this. Now check what we got. Alcohol. This is alcohol and this is also alcohol. Means ester on reduction will provide 2 types of alcohol. One from acyl part and one from alkoxy part. This is a technique in which you can learn direct reduction of ester. Just break your ester from here. Provide 1 hydrogen to this oxygen ROH this will generate, and do reduction of this carbon up to alcoholic stage, means break this bond from oxygen. So your acyl part will turns to this alcoholic part. For that, you can use these reducing agents: hydrogen gas directly in the presence of catalyst, sodium in the presence of ethanol, and lithium aluminum hydride. Now let's understand the mechanisms. Before going for the mechanism, first let's solve one reaction like such case is given. This is a ester, and here lithium aluminum hydride is written. So what will be the product? Lithium aluminum hydride is a reducing agent, means this ester will reduce. What technique I have told you? This part is alkoxy part and this part is acyl part. Now you need to break it from here, this one. So reduction of this part and reduction of this part will be separately done. When you will reduce this one, this alcohol will generate out, and when you will reduce this part, this oxygen will make bond with hydrogen and two carbons, this is first carbon, this is second carbon, will remain with it. This is another alcohol. Two alcohols will generate out here like this. In this fashion, directly you can solve the reaction. Just break alkoxy and acyl part separate and reduce them separately. Now let's go for the mechanism. How sodium and ethanol are reducing ester. Check. This is ester in which carbon is carrying partial positive charge. Because it is connected with two highly electronegative oxygen atoms, it is carrying a positive charge here. Now sodium. Sodium, we know what is the nature of sodium. Sodium will release out one electron. The valency of sodium is +1. During reaction, always it is release out one electron. Where that electron will go? Obviously toward a positive particle, because electron itself is a negative particle. It will go toward a positive particle. Where we have a positive particle, carbon is here. Obviously when electron will come toward carbon, the carbon require an orbital for this electron. So what carbon will do? Obviously bond will break. Pi electrons will shift toward oxygen because pi electron is a weak bond. So obviously it will break first. And our molecule will turns to this. Now this oxygen will carry 3 lone pairs with a negative charge, and on carbon orbital will generate. In that orbital one electron will be there like this. This will be the condition. Now this O negative will be satisfied by C2H5 ethanol. Ethanol is slightly acidic in nature. So C2H5 OH always break like this. Oxygen break bond from hydrogen. H positives are releasing out. These H positive will combine with oxygen to give you this. Now in one orbital, maximum 2 electrons can be present. So another sodium atom, this is first sodium atom I have utilized, another sodium atom will provide another electron, and that electron will enter in the orbital of carbon. Don't get confused, this is the first sodium whose electron was gone to the carbon and carbon turns itself to this. This is second sodium. Again, sodium is releasing one more electron and that electron will again go to the orbital of the carbon, because in one orbital, 2 electrons can be there. Due to which, because this is the extra electron which carbon is accepting, with a negative charge. Here negative charge will generate because now carbon have an extra electron. Normally it have 4 electrons around it, but here it have 5. 1, 2, 3, 4, 5. That's why it is carrying one extra negative charge. This negative charge will be satisfied by another ethanol molecule which will provide another H positive. That H positive will combine with this carbon. Means total 2 sodium atoms and 2 C2H5OH are consumed to make one ester molecule into this. This particle. One ester is getting reacted with 2 sodium and 2 ethanol to give us this particle. Now what I said about this condition, unstable condition, 2 oxygen on a single carbon and lone pairs are there, steric hindrance will be there. So what will happen? One oxygen will break bond from carbon, alkoxy oxygen like this, and when it will break, electrons are going toward with oxygen. So here vacant orbital will generate. That vacant orbital will be satisfied by this oxygen through making bond with the carbon. So when bond will generate, this H is as it is. From here H positive will release out. This hydrogen will release out as a H positive because it is losing electron, and this oxygen will release out as minus. Now 3 pairs will be there around oxygen. 1 electron is of carbon extra, that's why -1 charge. They will combine to give us ROH. So your alkoxy part will turns to alcohol in this fashion. Now what about this aldehyde? Aldehyde. Same mechanism will happen with aldehyde. Another sodium atom will release 1 electron. Keep there in your mind, ROH is already generated, one alcohol particle is already generated from alkoxy site. This is the aldehyde which we got from acyl part. Now same mechanism, this is positive, this is negative. Electron will go toward positive particle, pi electrons will shift. Oxygen will become negative because it is getting now extra electron of carbon, and in orbital of carbon 1 electron will be there. It's like this. Now ethanol particle C2H5OH will release out H positive. H positive will join with oxygen. Like this. Another sodium atom will release out another electron, and that electron will enter in the orbital of carbon, because in this orbital 1 electron was there, maximum 2 we can fill. The second electron will come here, due to which H carbon will become negative. Now this negative carbon will be satisfied by another C2H5OH particle which will release out H positive, and H positive will join here, and finally you will get RCOH H. Check this one. Which product it is? Alcohol. This alcohol is generated from acyl part, and this alcohol was generated from alkoxy part through a reagent sodium and ethanol. So this is the mechanism by which sodium and ethanol reduce ester to 2 type of alcohols. One with alkoxy part and one with acyl part. Let's go for the next reducing agent. Lithium aluminium hydride. Lithium aluminium hydride. Already 2-3 times we have used it. Condition we know. Lithium is carrying complete +1 charge. Aluminium hydride is in this condition. This one. 4 hydrogens are there. 3 are making covalent bond with aluminium, and 4th is making dative bond, due to which a negative charge is there. Now during reduction, because we know aluminium is unstable here because it is making 4 bond, -1 charge is there, so bond will break. Between aluminium and hydrogen, bond will break, and hydrogen is more electronegative than aluminium, so when bond will break, both electrons will shift toward hydrogen, and aluminium hydride will turns to this ALH3, and negative charge will release out because 1 electron was extra on it. Now hydrogen is gaining that electron, getting that electron, so charge on aluminium will finish. Aluminium will have vacant orbital and neutral it will be. Now what about this hydrogen? Because hydrogen is getting this extra electron, hydride is a hydride. Now this is hydride wants nucleophile. This is nucleophile wants electrophile. It will attack on a positive particle. Where we have a positive particle? Let's check ester. In ester, who is positive particle? This carbon. Because this carbon is connected with 2 oxygen atoms which are highly electronegative, so that's why it is carrying a high positive charge. That's it. This hydride wants positive particle. Here we have a positive particle. Attack on it. Now when hydride will come with its lone pair to make bond with carbon, obviously pi bond will break, and both pi electrons will shift toward oxygen because oxygen is more electronegative than carbon. So the next condition will be this. This oxygen will carry 3 lone pairs now with a negative charge because 1 electron of carbon it is getting. And this carbon will make bond with hydrogen, this one, and this negative charge will be satisfied by lithium positive particle. So finally we will get this. Here I am writing RCO negative Li positive HOR. This condition. Is it a stable condition? No. Again check. 1 carbon carrying 2 oxygens with a lone pair, highly unstable condition. In this condition, we know what will happen. Lone pairs will be shifted toward carbon and bond between carbon and oxygen will break like this. Because oxygen is more electronegative than carbon, so electrons are going with this oxygen. Vacant orbital will generate. That vacant orbital will be satisfied by this oxygen because this oxygen is carrying extra pair which it will give back to carbon. Now due to this rearrangement, we will get this RCO. H will remain as it is, no change. Now lithium positive will release out, and here we will have RO negative, this particle. Is it a final product? No. This is aldehyde. We want alcohol. So again the same mechanism will happen out. Now what about this RO negative? Look, after this applying lithium aluminium hydride, one more process is there which we need to apply, hydrolysis. After applying hydrolysis, we know what is hydrolysis. H positive and OH negative particles are there. So H particles will satisfy this, and this part will become ROH like this. But before applying hydrolysis, this particle will also get reduced itself with the same mechanism like this. Another lithium aluminium hydride will perform same action, will provide Li positive, ALH4 negative. That ALH4 negative will give us ALH3 vacant orbital and hydride. Aldehyde was generated. Again, this carbon is carrying partial positive, oxygen is carrying negative. So hydride will attack on carbon. Pi electrons will shift toward oxygen. RCO negative, H, and this O negative will be satisfied by lithium positive particle. Now, is it alcohol? No. And it can't break or make bond like this in this fashion because we don't have that condition. Such conditions are not available. This one. So this will not happen. Now what we do? We will do hydrolysis of that. Please keep this particle in your mind. Finally this we got, and then we will apply hydrolysis. Now what is hydrolysis? We know. Hydrolysis means breakage of any molecule with the help of H positive and OH negative. We got this one. Now it is very, very easy. H positive, this is oxygen which have a complete negative charge. That H positive will attack on it. Between oxygen and lithium, ionic bond was there, that will break. And this will generate. Li positive will be attacked by OH negative. LiOH will release out as a side product. Now watch this. This is alcohol. This alcohol is generated from acyl part. If you will check the mechanism again properly, you will find out this alcohol is generated from a acyl part. And from alkoxy part, I already told you. Please check that mechanism again. OR negative was generated. I said during hydrolysis, H positives will be provided. That H positives will combine with O negative will give you ROH, alcohol. ROH will be from alkoxy part, and this alcohol will be generated from acyl part. This is the mechanism we have for ester reduction through sodium and alcohol and through lithium aluminium hydride. Finally, note it down. The reduction of aldehyde, ketone and ester through sodium and ethanol, C2H5OH. It's a name reaction which we call Bovielt-blank reduction. Bovielt-blank reduction. Note it down. Very, very important. Name reaction it is. Aldehyde, ketones and ester. If you are reducing with the help of sodium and alcohol, and obviously they will be reduced to alcohol stage. They will create alcohol. This reaction is known as Bovielt-blank reduction. Name reaction it is. That's it. This is the end of the video. Thank you very much for watching the video.